Thank you, Josh. So, just a show of hands, how many people, like when we talk about edge, how many people here know what that means? Do I need to explain? Okay, so we're good. Okay, cool. So basically my goal with this talk is to frame it in such a way that we need to first understand, like, building platforms and workloads for edge is a different set of challenges, like compared to if you were running things inside of a data center or a cloud. So I want to start off from that perspective, right? So understand that, and then kind of get into basically 3 main projects that are going to kind of help us. So hopefully you'll be able to connect the dots. Just to tell you guys a little bit about myself before I get into the talk. My name is Ram. I'm based out of Seattle, work for Red Hat, been with Red Hat for about 5 years now. Before working for Red Hat, I used to be a platform engineer for T-Mobile. So I ran a lot of their container platforms. So I was part of their team throughout the whole journey of like modernization. So I have a lot of experience running platforms at scale. At Red Hat, again, I'm a part of this global solution architect that focuses on industrial edge. So edge can mean different things. We primarily focus on industrial edge, so like OT, operational technology. We do get some retail stuff, so we, anywhere there's revenue opportunity. I mean, I'm part of a pre-sale, so we always, we never say no to the money, right? But anyway, the primary focus is industrial edge. But most recently, even more specific, I've been focusing on substation modernization. So I work a lot with electrical engineers, basically working on modernizing protection systems in substations. It's been a pretty fun journey. Edge is pretty interesting in my opinion. Like, I came from IT, as many of you guys probably still doing IT, workloads and things like that. Edge is very interesting. There's a lot of opportunity to actually take all the learnings from the IT and cloud environments that we've had, and now we can actually apply it. So, especially in the substation use case, like I'm learning a lot of new things, and they move very slow. So it's kind of interesting. You get the itch of trying to do the latest and the greatest, but then you have to be careful, right? Just like everybody understands the software brings a lot of value, but it can also bring trouble, right? Like one line of code, bad code getting in, if your protection systems are down, that's a big problem, right? Somebody could die, some equipment could get blown out, right? So a lot of you have to be careful, right? So that's a little bit about myself. So this is what we're going to do. So I'm going to talk about some of the common challenges, some of the differences, like when you're running platforms and workloads at the edge. And then I'm going to get into there's a technical overview, like with Microshift, Bootc, and the components around, like all the platform, all the things that was going to help you build and manage a platform to run workloads at the edge. It's a small talk, but there's a lot of things packed in there. So, I know I'm kind of jumping from talking about the challenges to like an overview. It's at a high level, so we're not going to go too deep. But at least it's kind of nice to see the big picture first, and then from there we'll kind of unpack a little bit, look at Bootc, why Bootc is interesting, and then look at Microshift. Microshift is the Kubernetes. If you want to run Kubernetes at the edge, that's an option. So we'll unpack a little bit, and then the last bit there is the project flight control. So that's all about fleet management, right? So when you think in the edge use cases, it's not just a few servers, right? You're talking about lots of edge devices spread across all your, like for example, in the manufacturing plants, you might have multiple manufacturing plants and substations. Some of the utilities have 80,000 plus substations. So if you think about number of devices, it's quite a lot that you have to manage. So project flight control helps you manage your fleet of devices. So we'll take a look at that. Again, there's a lot of 3 different projects. You can spend a lot of time in any one of those things. We're not going to do that. My goal is to give you guys a flavor of these 3. These are core components that you're going to deal with when you think about building platforms for edge. So with that, I'm going to jump right into it. So in terms of, as I said earlier, like it's not, when you think about building and deploying platforms and workloads at the edge, it's not like your traditional data center or cloud-based workloads. So first thing is, you have limited resources in edge environments. Unlike, you don't have the luxury of having server infrastructure. So devices are small. They need to live in like extreme environments, right? Like in a manufacturing plant, like you're talking about like the in industrial grade environment where it needs to survive the heat. So I have a customer where they run their edge device. It's a 911 security thing. Some of these devices are in like extreme cold places where you can't get to, right? So edge environments are different from traditional data center. You don't have the luxury of resources. So that's one of the biggest things you have to keep in mind when we think about deploying workloads and platforms at the edge. The second one here is these things could be in hard to reach locations, as mentioned earlier, like Alaska or even extreme locations where you can't send somebody there. There's not IT people. Like actually, if there's a problem, you don't have somebody that can actually take a look at it, right? So that's So that's the second challenge that I have here. And the third one is essentially, and I think we talked about it. You're talking about lots of things to manage, and in hard to reach places. Everything needs to be manageable remotely. If something's wrong, you need to be able to remotely. The resiliency becomes important, right? In a manufacturing site, for example, if one of the device that's actually part of a process automation, if that device is not working or the workload that's running on it has problems, you have to be able to take care of those things remotely, right? So these are at high level. Obviously, there's probably more we could think about, but at the core, when you think about edge, these are kind of the three main things that we deal with. Any questions before I jump into here? Feel free to stop me if you have any questions or something's not clear, if I'm moving too fast. So this is essentially a big picture of if you were to build a platform, like, so let me kind of walk you guys through this diagram. So on the top, you can see those are applications, right? If you survey, like any customer, you have like, not everything is always going to be containerized or not, so you have these different spectrum, right? So some are going through a transformation. So on the top, you can see if you have a Kubernetes workload, your applications could be a Kubernetes application. Your application might have gotten containerized, but maybe not ready for Kubernetes. So you have a containerized, that's the container box, right? That basically means you may be containerized. And then the other one is the virtual machine, right? So it's a legacy VM app still running on a VM, maybe going through modernization, maybe you just want to keep it running for a certain amount of time. You don't want to, and then maybe that gets retired, right? That makes no sense in investing in modernization, right? And then the last one is the traditional way of running applications on Linux platform, like RPM app based, right? So the key thing there is, depending on where you are in your app modernization journey, you have an option for each one of those type of workloads, right? So workloads could fall in any one of those buckets. So going down the stack, you have, so that's the Microshift is basically that sits on top of that platform, the OS, right? So that's what provides the ability to run, Kubernetes applications. And we're going to unpack that a little bit more. In later slides. And then you have Podman, which is our container runtime to run containers, right? So in edge environments, like Podman is actually pretty decent for most use cases. Like you don't really, need to jump straight into a Kubernetes application, right? Like you might want to start container, run it on Podman. And then once you get some experience, you might gradually migrate that into a Kubernetes. So Podman is really a good option, and again, We're not going to go too deep into Podman in this talk, but again, like I said, if there's interest, we could do a follow-up. There's a lot of nice features when it comes to running containerized applications on edge devices. And then KVM for running virtual machines. So if you have a VM, legacy VM, you can run on top of KVM. And then obviously systemd for your traditional RPM applications. All of that sits on top of a Linux operating system, right? So you have basically Fedora, CentOS Stream, different options there. So that's that's kind of at a high level. Those are platform components. So the things that you see in gray are stuff that if you were to assemble, that's what you would bring, right? So the things in blue are upstream projects that are out there. You don't have to engineer and build these things. It's out there for you to actually consume. Obviously, there's upstream and then downstream components to this, right? I'm assuming you all know how Red Hat builds software. So anyway, that's kind of in a nutshell. If you were to visualize a platform for the edge, this is kind of what it would look like. Good? Make sense? So now we're gonna jump into bootable containers, which is kind of one of the core components of this platform, right? It starts with OS, right? So bootable containers is a new project. It's a new way of building and shipping operating systems. So before I kind of jump into the details of Bootc, I want to kind of talk a little bit about common challenges. If you're an IT person or an infrastructure person responsible for building operating system images, it's a lot involved, right? When most companies, I don't know if you have what your guys' background are. If you look at most large companies have a standard, basically a team that builds standardized golden images, right? Because you're running infrastructure on premises, cloud, edge, right? And you need to have a standard image that you use to deploy everywhere, right? So there's a lot of while it sounds easy to say, build a golden image, there's a lot of complexity there when you think about kind of a large infrastructure organization that's providing that service to entire company, right? A couple of things that I want to kind of call out here is building a standard image. There's depending on if you're doing it bare metal, cloud, different cloud environments, different virtualization platforms like VMware, Hyper-V. There's a lot of complexity involved in building and targeting multiple deployment models, right? You have to understand the different tools to use and how to build and kind of a repeatable process of building these images. And then testing and validating, right? So it's not just build and just use, right? You need to test and verify that it meets the security requirements, compliance requirements. It has all the enterprise tools installed in it, things like that, right? And then the big one that I've seen personally is I used to work, when I was at T-Mobile, I used to work with a team that built golden images closely. And the problem when you look at a large organization like a telco, where you have many teams, it's hard to get everybody moving at the same pace because the change is happening, right? You're making changes to the image frequently. So what ends up happening is now you have to support multiple versions of that image, and now you have to track who's using which image, and then you got to be behind them to get them upgraded. So it is complicated. It gets really challenging. And then I think the rest of it, it's pretty self-explanatory. But the last one I would say is the security, right? How do you make sure security, it's constantly updated. So those are kind of some of the challenges that you have today in terms of you're an OS builder, building a standard image. These are some of the things you have to have. What you'll see here, if you look at how, what the application teams, the journey that application teams have gone through in terms of containerization, right? Containers have really revolutionized how we build and package applications, right? I I don't, everybody would agree with me here because we've been using containers for quite some time, right? So you have, standard OCI format for delivering. You take your base image, you put your application files in it, you package it, and the container tools have matured immensely. You have, there's a rich ecosystem around security, like you can run, sign your images, scan your images, like all those things, like the application teams have like literally leapfrogged OS people, right? So I just put this slide here just from a perspective, just to get a perspective, right? Like if you look at application teams have really gained a lot of value by going in this container direction with packaging and deploying an application. Bootc is going to bring that into if you're an OS builder, we're bringing that same experience in terms of how you build and deploy operating systems, right? So if you look at in this diagram, you'll see this is what we do today, right? Like somebody builds this image, they're basically assembled, your operating system is assembled with a set of packages, and then the people that do this, and then the people on the other side, like building applications, they're taking an image that runs on these systems that are built by these guys. So they don't talk to each other, right? If you look at that's the model we have. With the middle, with Bootc, what you're gonna see is we're bringing both the worlds kind of together, right? So now you have just, your operating system is the image, you place your applications in that image, and together they go as one thing, right? And that's huge, right? So if you can avoid a lot of that friction that was there between the infrastructure people and the application people, right? So now they can be talking to each other. If something's wrong, they can collaborate. So that's really a good thing, right? So in a nutshell, that's what Bootc is all about, bringing those two worlds together so that you can basically use the same set of tools. So like all the way you build applications, the way you build OS, like it's the same container tools you build your OS, which means now I can scan the container image for security vulnerability. I can sign just like I've done with the application images, right? So there's a lot of reusing a lot of that skill set and learnings that we've had from applications world. Make sense? Quickly moving on. So this is just basically, we're just reiterating that Bootc is, basically it's going to bring both application and OS people together, and we're going to leverage the same set of tools across so you get a consistent experience. Just some benefits you can get, right? So speed to, time to market. You tremendously increase the time to market because you can leverage a lot of the DevOps practices that you have your application teams have been using. The second one, the streamlining operations. So this is one of the cool part is if let's say you make change to an image, and if something breaks the application, like that change breaks the application, there's a feature inside of Bootc called Green Boot. What it does is, Green Boot, when a new version of application is operating system update is pushed, it will, every time it'll pull down the new updates, and then the Green Boot health checks run, and if all those health checks succeed, then the new version of the operating system, it'll boot into the new version of the operating system. If any of the health check fails, it's going to automatically roll back to the previous version. So remember, in edge environments, if an update breaks the device, it's very important to be able to roll back. So this is a very key feature for edge, but if you think about it, it can actually be beneficial in IT, like a regular server environments as well, not necessarily just for edge. And then the security, because bootable, Bootc images are immutable. Basically there's parts of the operating system you cannot write. There are mutable parts, which means your attack surface you tremendously reduce. You don't have the issue in the package mode world where when you make changes to your image, now the provision systems need to also get those new changes. There's challenges in the package mode world, but in Bootc that goes away because the provision systems will automatically, I'll actually show you this in a demo. They will pull down the updates, and if everything looks good, the new version, it'll boot into that new version, and that happens without you even knowing. Application teams can introduce their own health check to make sure that applications continue to work. And like I said, you have the security, you have enhanced security with all the, the container signing, container scanning. I think the last bit here is the most important one, like the appliance model. Like it really fits into like an appliance use cases where you're building, like an AI use case is a classic, use case for using this kind of technology, because you can package everything like the workloads and drivers and everything you need into an appliance and then provision. This is a high level, the workflow when it comes to building Bootc images. So you start with a container file just like an application, like when you were containerizing an application. And then you use the container tools to actually build the container image, and that image then gets pushed into a registry. That image is still not something you can use to actually boot into a bare metal a device or even virtualized environments. We need to convert that into like a disk format. So that's the other process. Once you have an image, you use a tool called Bootc Image Builder. So image builder tooling has been around. So if you look at the OS build ecosystem, you will see like that's what we use today to build OS images. So you define a blueprint, and it can actually basically build your OS image using that blueprint. So in Bootc world, what we're talking about is instead of a blueprint, it's a container file, right? So and the output is container image. So it's the same ecosystem, OS build ecosystem for building images. So you basically, for Bootc, you take the container image, it will convert into whatever format you want it to, right? So it could be an ISO if you're deploying it on bare metal environments. It could be an AMI if you're running things in the cloud, in AWS, for example, which is what I'll show you. But you can, this is kind of the cool part, is like once your image is built, you can deploy that image anywhere. So you use Bootc Image Builder to actually build an ISO if you're deploying to a bare metal. If you're doing AMI, you create an AMI, and then you can deploy it on AWS or any public cloud for that matter. So that's kind of in a nutshell the workflow around building images. Like I said, you would, in a real world like this, once you have your operating system image, what your developer teams could do is they would basically create a container file that will use the operating system image as that base, and then overlay that image with the applications. So now you have a kind of a combined, right? Applications and operating system combined. So this is what we mean that earlier slide. We're bringing those two worlds together, and that's huge. Like that's a big change, and it's something that's going to benefit everybody. All right, so moving on. So this is basically showing the list of distributions that are actually shipping bootable containers. It's right there. I won't go too much. So if there's no questions, I will jump into the next topic, which is Microshift. Yeah.
Were there any like design decisions there that inspired changes in the general pattern of deployment here?
Do you want to take?
Yeah, it's actually people come in with very similar solutions to serve the same needs, right? Because like the real parallel to NixOS is something called Universal Blue or Bluefin, which is a desktop OS that you can see. Actually run it on the laptop. The Nix folks were very focused on, or are very focused on security. Universal Glue, which uses Bootc, is a little bit more focused on maintainability. But you know, in principle, very good.
Actually, I can tell you the little bit of history behind this. This is actually pretty cool. So if you think about, anyone here knows about atomic host? Heard about atomic host? So if you look at even underneath Bootc, there's something called OS3. It's basically immutable. Like it used to be. Behind the scenes is OS3 base operating system. It's essentially the idea that your entire OS is immutable, right? The file system. So the OS3 started with atomic host. It was originally used to be atomic host, and then that became the container OS for OpenShift. But OS3 still became, edge for edge use cases. It became the core OS. Before Bootc, this is what we used to build for edge use cases. We build OS3 base systems. So again, it's this idea where you have you define your edge image in a blueprint, and then it spits out the OS3, like the repo. It's kind of this GitHub kind of concept where every change is a commit, right? And you can see the exact files in that commit. And in the repo maintains the list of those commits. And so that technology is still there behind the scenes. You just don't interact directly with Bootc. You don't interact with OS3 anymore. But behind the scenes, what was it?
Which is a good
thing. Go here. So first thing that I will kind of show you guys here is building the Bootc images. So I have three images down here, but one is basically this is the base image. Yeah. This is the base image that has the flight control, flight control is our fleet management solution. So it has an agent that runs on the device that essentially calls back to flight control backend to make sure, am I still compliant with the desired state? And if not, it'll make the device compliant. So this image has the flight control agent in it, which you can see here. And then I installed the Podman Compose tool. And so what we do is, so we build this image first. I've already done this, but I'm going to kind of walk you through, right? So in here, I've to make things simple, I have this make file here where I just say make base, right? The steps, to build that base image, is actually here. You can look at it at your own pace. It'll take some time to build it, but that's, so I build the base image first. And then what I wanted to do was, I didn't want to put Microshift, because sometimes if there's a scenario where you don't need Microshift, why run it, right? So that's why you see the second image. That image is essentially derives from that base, and then I overlay with Microshift bits, and then I use that. If there's a workload that you want to use Microshift, you use that image, right? So I've also built that image here. So again, you can see in the make file, you don't make Microshift, it will build that Microshift image for you. And then the last bit here is the Cloud Init. Anyone here heard of Cloud Init? Okay, so I'm using Cloud Init to do initial first boot, things like creating the admin user, adding the agent enrollment certificate to onboard the device into the flight control platform, management platform. Those are all injected via Cloud Init, and so the Cloud Init image, basically, again, it uses a base image. You can give it the base image that doesn't have Microsoft, any one of those two base image, and it will overlay with Cloud Init, and then that's what I use to provision into Cloud or Bare Metal. You can see down here under playbooks templates. So this is the cloud config file. It's, again, I'm using Ansible to actually spin up spin up the device in virtual, in EC2. So you'll see down here, I'm specifying the user that I want to create, and the what's really interesting is down here, right? So it's doing the first boot steps like starting services, and then injecting the agent credentials down here. You can see, and then essentially, what I do is when I want to provision a device. So first thing I do is I build the image, right, using make, and it'll push it to registry, and then there's a command in make here called make AMI. If you look, make AMI is where we're using the Bootc image builder to actually build that AMI image, where I specify the container image, the operating system image, and then it'll use the Bootc image builder to actually make an AMI. And you can see that here. If I log into my AWS environment, I already have the two AMIs here built, right, for those two images. And then under EC2 instances, I have provisioned the device one. I was going to provision the device 2 here, but we're running short of time. But let me quickly SSH into the device and actually show you, like, it is actually deployed that container image. So let me go here first. Security groups. I need to make sure I grant this, update the rules because it changed. So then SSH. So I'm actually SSHing into that device that I provisioned using that image. So now I'm actually on the device, right? So imagine this is AMI, like EC2 instance, using that same container image, use the Bootc image builder to create an AMI, EC2 instance provision using AMI. It could be a bare metal, it could be the same thing. So if we do sudo bootc status, you'll see that it's actually using that, this system is deployed using that image that you see right there at the QuaIO ARP. Let's see down here, Bootc base. So if I make any change to the container file and do a rebuild, and I can come here and then say sudo bootc, update. Right now I didn't push anything, but if there was update, new changes to the image, what it'll do is it'll pull down those those updates, and then when I reboot, those changes will be applied. And if something goes wrong in that new version, it'll automatically roll back to my current good version, right? There's also a job that periodically runs, and it'll look to see in the registry of the changes, and if there's changes, it'll pull down, and then next reboot, those changes get applied. That's quickly like the whole, how you build and manage the update. The other part to this is like really with the flight control. So let me just quickly show you that. So I'm going to log in. So I've deployed flight control. All of this stuff is actually in that repo, like the the Terraform scripts to deploy Kubernetes cluster and even flight control, like all the stuff. Like I will add more documentation. So if you guys want to follow it on your own. But this is the bit that's actually super interesting. So here, so notice, like, I just have an image, right? It doesn't have any applications in it, right? So what we have here is, this is our flight control, like fleet management solution. What I have here is, you'll see here, I have defined my fleet, right? What a fleet should look like in my Git repository. So if we go back to my code here under Visual Studio, under fleet, you'll see here. So flight control allows you to declare a